Today we are going to dive into the realm of epigenetics, which is the changes in an organism caused by modification of gene expression rather than alteration of the genetic code itself. One must consider all environmental or outside factors to determine the causation of epigenetic effects. Taking our view to a DNA level, epigenetic effects are usually in the forms of methylation or acetylation. The occurrence of these forms on the DNA strand are known as epigenetic tags, which is part of the individual's epigenome. The result of these tags is certain genes being turned off or on, or otherwise having their expression impacted. DNA methylation is an addition of a methyl group, usually on cytosine or otherwise known as a CpG island. This methyl group can inhibit transcription. Acetylation adds an acetyl group to the DNA molecule, which affects the histones, with histones controlling how tightly wound or loosely wound the DNA is. This acetylation can greatly influence transcription and translation, as you can see from the strand. The genetic code gets easier to read as it's unwound and can be translated then. Analyzing Grumpy Cat's entire genome here, with each paper roll representing a chromosome from conception until death. As you can see, the Grumpy Kitten's DNA already has some epigenetic tags that were likely created from imprinted genes from her parents. Then throughout her entire life, these genetic tags remain, drop off, or have additions made. Consider she was overfed Fancy Feast Tuna Delight from a young age. This occurrence would leave certain genetic tags on her genome, possibly leading to obesity. Yet another factor, like living in a house with humans that smoke, could enable or disable other sections of genes. Now, let's take a look at a more application-based example in the cattle industry.
Epigenetics in the cattle industry is more common than you may think. The environment of a beef operation can make the industry's best genetics better or worse. Genetic potential can only be achieved through adequate measures in any extreme. For example, we have two flushmate steers, meaning same sire and dam, who have been sold to producers, one in Arizona and one in Virginia. The steer being raised in Arizona will experience humid desert conditions with a grain-based diet. The steer being raised in Virginia will experience cold temperature and mountain terrain and will consume primarily roughage with an added protein supplement to control the nutrition deficit. The steers will be fed in these environments until they reach 700 pounds. Once they reach 700 pounds, they will then be transferred to a feedlot in western Kansas to complete the finishing process. We will experience the most epigenetic effects at the feedlot, as the Arizona steer will adjust to the environment easier than the Virginia steer. It will take the Virginia-based steer longer to gain its finishing weight and will most likely cause the steer to bring less when sold at the packing plant.
Analyzing these steers' genomes from a young age, an individual can see the changes in epigenetic tags over time. At birth, the steers have very similar genomes, but as they grew older and experienced different things, alterations happened. The steer located in Arizona had to deal with hot temperatures and was fed a grain-based diet. Each of these outside environmental factors add epigenetic tags. The steer located in Virginia grew accustomed to cold temperatures and certain epigenetic tags were disabled, while the protein supplement he received enacted growth genes. When both steers were brought back to Kansas for slaughter, the Arizona steer outperformed the Virginia steer by having a much heavier hot carcass weight. The epigenetic tags the Virginia steer had led him to be less receptive to starting his sympathetic nervous system and deal with the hot summers in Kansas, while the Arizona steer adapted easier to Kansas climate and prospered as such. This is a classic example of how important cattle's environment to their level of productivity and efficiency in terms of beef production.